Now everybody can consent to being recorded. Something new.
Yeah, how about your inventory? Can we call you now Ken the Count?
Well, it actually went really well. So we counted several million parts and we are 99.97% accurate on inventory, which makes me wonder why we actually did it. But where it really matters is, pardon, Chip?
Where were the inaccuracies?
They're always on components for manufacturing, little bits and pieces. And those are actually the low value parts, are the most important ones to have right. Because we go to set up for a job and then it's like, this reel's short, what's going on? So we've been running things a little bit too thin in terms of inventory for a while. Anyway, it's great, thanks. Well, welcome everybody back after a little bit of a break. Seems like, Chip, we had a lot going on, didn't we? Chip was cooking food for 75 kids and had some other things to tend to. So, and Johnny Mac has been wrapped around spin PASM code that isn't fixing itself. And so we took a few breaks. So today we got a couple topics and a list of other ones. So let's just jump right in. This is provided somewhat for humor, but also to answer a question that I take all the time, which is, will the fill in the blank product still be available in 5 or 10 years? And often it's, lately it's been the Propeller 1. So I just point this out to show you that, yes, everything will always be available, especially if we make it and we control it. So here's the BS1 from 1993, actually originally made in 1992 by Chip, but this was, what is this? How many years ago? Almost 30 years ago?
28.
Yeah, and we have 212 in stock and we sell 40 a month. So as it relates to the P1 and P2, people are a little nervous about our P1 shortage right now, which is absolutely aggravating, but a couple things happen. The lead time from the foundries went up on us very quickly. And then customers started placing orders that we didn't expect and knew nothing of for projects that we didn't know existed. And things are filled in the sequence they are received. So I keep banging the same story out here that if you are a Propeller user of P1, place your order with a lead time of 20 weeks, and this will help us immensely. Otherwise, all we could do is fill your order in the sequence it was received. So if you know where you're going, you're sure to get there, especially if we know where you're going. And P2s we have plenty of in stock. So at the moment on the P1s, we're, I don't know, 25,000 units upside down with expectation to be out of that by October.
Yeah, one could say that it is a good news when you can sell more than you are able to. It's basically good news.
Yeah, it is. We have to test them inside Rockland, which isn't so fun. And it's probably the most difficult job in the business, but P2 thankfully is tested at the die level. Or is it post-package, Chip?
What's that?
P2 is tested post-package and die level, right?
Yeah, does the whole test. On semi does the whole test.
So switching over to documentation, this is definitely going along consistently, albeit slow. So there is, I'm going to show you what we have and where we are with each document. The spec sheet, which is kind of our one-page high-level marketing information for the manager, what can the P2 do sheet, is done, has been done, and is posted. So no changes there, 100% done. The data sheet sits at 50% complete in terms of what is published, or 80% complete from the author's viewpoint. So the work there lies with our editor and with our test and characterization efforts, which are underway. So we expect 2 to 3 more releases of this. Of course, it's never done, but it's going to be more done. And the link to the latest data sheet, which was updated just a few days ago, is posted in the chat. And at the very end of the data sheet, you will see what we have changed or added. So I've just copied those notes out of the data sheet and put them here for everybody. And then the big bulk of the work that really a lot of people want, which is to show us how to program more effectively on the P2, is in this state. So there are 3 more documents in the works. The P2 hardware manual, which this is fun. This is 10% complete, but Jeff says we'll have a 125-page draft in mid-August. So divide the number of work days by the number of pages and you'll know Jeff is very busy. And the PASM2 manual, what's done is pretty much just some groundwork organization, probably from Chip's spreadsheets. And we have no release date for that. So we have only 5% complete. And the Spin2 manual is really in the same position. So it seems like we'll be working from Chip's shared Google documents for quite some time on those. Any questions on documentation? I didn't give us much to discuss.
I have a big one. What's a microcontroller with a P2?
Well, right now we're finishing up a 1-year effort. What's a microcontroller with Python, which we call internally WAMPy. So that's where we are. Nothing yet planned for P2 in that way, but our educational resources may or may not be available in the next couple months. We'll see. And if you read these documents and you have comments, requests, or anything, just send them to editor@parallax.com. And Stephanie will round up the appropriate people. So the big thing is, as we see it right now, is that Chip just will be 100% available for Jeff all the time. Moving on, feel free to unmute yourself if you have anything to say. So the BLDC system, from a hardware perspective, cover that first. We actually have these motors in stock at Parallax now, and they look good. So we have a good supply, and we're actually getting more in the queue on a boat because it takes about 3 months to get them these days, plus any time at the port that adds up. So in the upper right-hand side, you see the motor, they're 6.5 inches. And on the left side, you'll see the bearing block that we're making. And we put in Chip's shop, just behind Chip, there's a big metal building, which some of you have seen, and has 2 CNC machines in it. And on August 4th, it's going to have 2 more CNC machines in it. It's going to have a total of 4 Haas machines for making Parallax parts. So we're moving our CNC stuff up to Red Bluff. Anyway, this bearing block is designed with to clamp this round shaft of this hoverboard motor where it's flat with 4 beefy screws. I think they're 1032 or 1/4x20 cap screws, I'm not sure. And then on the edges of the block, there are 4 1/4x20 drilled threaded screws for mounting this on the chassis. So it's kind of similar to all the other mounting options we've provided in the past, where you can mount a deck on top of the robot and then a deck underneath to keep it from splaying out like a tired basset hound on a hot day. You know, so the wheels will stay true and vertical. And then the cable comes out the back, and then the little recesses are so you could run any wires that you might have for sensors. It just provides you another place to channel things and tidy up the wiring. So we have 200 of those made, and they're getting anodized right now. And this drops the cost too for the robot enthusiasts compared to our old system, the motor mount wheel kit, which was $300. We expect this to be quite a bit less because there are just so fewer parts. And there's no bearings and external stuff, no external encoders or electronics to add to the motor. So for the caster wheel, we're making something very durable based on Herman Miller Aeron casters, which are quite low cost. There are these rollerblade wheels, and then we're making an adapter, which allows you to screw this into the bottom of a chassis of a robot. And the whole height of the deck would be matched up with the top of this bearing block. So for bigger, faster robot system, we have bigger, faster parts. Any questions on this hardware? And we'll provide more pictures in the future. Interesting? Do you like the look of it?
Actually, Ken, for me, that bearing block looks pretty small. I mean, compared to the, shouldn't you do it a little bit longer? I mean, maybe 3 screws each side.
This is surprisingly stout. You know, we haven't done any tests on it, but I think it's the length of that shaft, which is 3 inches or so. So it's a very firm grip, and if your chassis is strong, it's not going to move around on you.
Yeah, it's pretty rigid. And I just was out there a minute ago, and Doug added a little positive step to where the flat is captured of the motor axle. So you'll be able to get a very good grip on it. The whole thing's pretty rigid. I think we had a motor mount before that only grabbed about like 3/4 inch of the shaft, which is not very good engineering, but this thing grabs the whole shaft and then has these, are they 1/4-20, Ken?
Yeah.
Screws. You'll be able to get a very positive grip. And that caster wheel is designed, like 5 of them are good for, I think it said 250 kilograms. It's like 500 pounds. So that each of those can do 100 pounds, which is way more. I mean, the robot's going to put probably a 5-pound load on that.
So for prices, the hope is the caster wheel with the adapter, like 25 bucks. And the wheel itself, you could just compare on Amazon what they sell for. I think they're around $38, $39 or something. We hope to be able to match that. And maybe a little bit more, maybe up to 45. And then the bearing blocks are going to be about $30 as well. So you can add up those numbers, and I think you can build a very powerful robot for pretty low cost. Okay, moving on, let's talk about the hardware. So Chip, I have a few pictures here. I have a link to the schematic that I could post. And so we could really start anywhere, just showing you what I've got, and we can come back and talk to these and zoom in on them.
Yeah, so what we have here is just a 4 half-bridge board. So we can run like 2 DC motors, regular brushed DC motors bidirectionally. We can run brushless DC motors, which require 3 phases, and we can do steppers, which require 4. So this is super flexible, and you can see where the screw terminals are. We just numbered the signals U, V, W, and then added X for the 4th. And then power screws down into the middle. You can see where the FETs attach. There's a high side and a low side FET for each half bridge. And then there's some driver chips back behind the caps on the left side of the caps. So this is going to be useful for any kind of prototyping for motor control stuff. And then when it comes to these hoverboard wheels, which have the motor in the hub, they all have these 5-pin connectors. So if you see in the upper right of this board, there's this thing that says 5-volt UVW and ground. That is useful for figuring out where you need to apply the current in order to run the motor most efficiently. And then you can go to the schematic, Ken.
Okay, I'll drop a link too. I put it up on Google Drive so anybody can get to it.
Yeah, this board, because we need like 10 volts for the FET drivers, it has a switcher. We couldn't really pull that reliably off of the little connector and try to boost it up. So what we did is we took the 40 volts in and added a little switcher here to generate the 10 volts. So we have plenty of current for the gate drivers, for the FETs. And then we have even a little 5-volt regulator down on the lower right, which is just for running the Hall effect sensor, which is that 5-pin connector. And so this gives you, let's see, here you can see where the Hall effect connector comes in. And go to the next page, Ken. We've got the schematic down to 2 pages, which should please Ray a little bit. It was like 4.
So is anyone having any trouble zooming on the schematic? I did put the link there. I can also zoom in on it here while Chip talks about it. That would be helpful.
Phase U. That's because there's 4 identical circuits here. Can you zoom in on phase U, Ken, so that becomes bigger?
Yeah,
Like
how about if I just open it up in Drive?
Yeah, and just look at the upper left block. So this is almost done. This would have been done a long time ago, but Michael's had to take a lot of tours for some educational robotics stuff, which is
Okay. Hang on just a minute, Chip. I'm going to download it and get it handier.
all right. We've gone over this circuit before, but it's pretty simple. We're using a microchip FET gate driver, which just requires 1 external capacitor. And it has the diode internally for making the flying, high side FET gate supply.
Yeah, question is, I mean, those wheels have a Hall sensor, but you did some experiments with kind of measuring the phase or position by measuring the non-activated coils to get kind of a steering there without any. How far is your thinking about that part yet?
Yeah, you're talking about the field-oriented control concept. If you have the Hall effect sensor, it takes all the guesswork out. You can just know with a certainty exactly where you're at and how to apply the current. Okay, Ken, go to the next page of the schematic and then zoom in on the upper left. There we go. So here's what we have, four circuits like this. So you can see that FET gate driver, which is the chip. There's some bypass on the left, and then there's that little flying cap, that 1 microfarad. And so this allows you to use 2 NFETs for both one for high, one for low. The out U signal is the high current output that goes right to the motor. And then this is the sense U is the voltage divider with current limit, so that you can sense the voltage at any point. And this is most useful for measuring after you turn the bridge off and the field collapses. You want to know how much EMF there was. So that's what this is for. And the way it's drawn, it looks kind of funny. Really, it should be like, that horizontal and then the lower vertical cap should both be vertical, and then that upper vertical cap should be horizontal. So it's just a tap off of a resistor divider. That's what that is. But you drew it like this so you could fit 4 on a page. So we've got should be good for 40 volts and I think 25 amps, but most of the power dissipation is not going to be from the switching at all. It's going to be it's not going to be switching current to the load. It's when those fields collapse and you see these diodes from S to D inside these FETs. Does have a forward drop of like 1 volt. So that's where all the power, that's where the heat's going to come from, is when those fields collapse, they're going to heat that. But switching the current to the load is not going to generate really any heat at all. And then go down a little bit, Ken. So you can see that we have a voltage sense for each of these 4 legs, each of these 4 half bridges. And then now go down to where it says current sense. Then we have this one with this 50 milliohm resistor that we can tap off of, and that is that's the overall current. Because in practice, you're only energizing one bridge element at a time. So, or one low side at a time. So you're always looking at one, but rather than have like separate current senses for every leg, which would be redundant, because only one's turned on at a time, we can kind of group them up here. So this 50 milliohm resistor is going to get, some millivolts across it, which will indicate how much our overall current is. So this should let you do anything you want with motors. And you can hook up pretty good size motors too, as long as you don't overheat those FETs because of back EMF. And then we have that varistor. Reza, I don't know if Reza's on today, but he had talked about this. Let's see. I don't see him, but this is a varistor or a, there's another name for this, I can't remember. But this thing just clamps on when the voltage gets too high. So it's like a protection mechanism, which hopefully doesn't normally get turned on, but it's there in case it's needed. So that's the motor board. Hopefully done soon.
Curious if when you're working on this with Michael, if you guys checked component supply along the way. I assume you did.
Well, the hardest thing to spec were the FETs because there's about 1 million options. And I think we had a lot of discussions about it, but I think in the end he went with a package which many different FETs come in so that we can choose, alternate vendors if we have a supply problem. And they get decent heat dissipation. So,
Chip,
yeah.
Ken, can you just scroll down just a little bit? I want to look at that. Capacitance and protection, right. That's good enough. Those capacitors sitting off with 40-volt rail, Chip, 50 volts and 60 volts is nowhere near enough. Even though you've got a varistor protection on it, you're still likely to see spikes above it. You always have to double your voltage rating on capacitors, otherwise they'll die.
Yeah, I remember you saying that, and okay, let me write that down. So, what the next step up really is like 100 volts, right?
Yeah. Your
So
50s way too close. You'll find that they'll die.
Yeah. Okay, so use 100 volt electrolytics and X5R. Okay, thanks, Ray.
What else, Ray?
Yeah, we'll revisit that.
Also, and as far as I remember, the resistor should be a little bit less than the voltage, and you have now 40 voltage in and 42 on the resistor. Shouldn't that be 36 or something?
Maybe. Yeah, I can see that thing down in the lower.
I remember the discussion in the forum that whoever told you about that, he said it has to be a little bit lower than the expected voltage. Because they are reacting not as fast as tuners.
Which part, Chip?
Lower right.
Lower right. Again, okay.
The lower right corner. It's now currently at the 42 volts, and it should be 36 or something.
Yeah, well, I wonder then if you run at 40 volts DC, is that thing not going to be somewhat turned on?
Yeah, you need it to be a little bit higher for safety, because you will get spikes above it, and you don't want to turn it on inadvertently.
Yeah, but that's the opposite to what the guy told, because he said 36 would be good because they are not reacting as fast as tuners.
Yeah, but if you've got 40 volts
to kind of
okay,
so
here's something.
the reason he said we should take lower voltage as the expected.
Well, here's how I remember Michael and I were talking about this. We're going to rate this whole thing for 40 volts, but the fact is it can handle more than that. So it could, you probably run it at 50 or 60, but we're just going to say 40. So in that case, I think this would be fine because it's not.
Yes.
You clamp everything completely by 50 volts, we're fine. But we don't want that thing turning on and causing a load at, you know, within the voltage rating of the board.
Yeah, it's got to be above what your standard voltage is.
Yeah.
Otherwise it's going to be on all the time, which is not what you want.
No.
What else? I like it.
Chip, I just noticed back up on the left the capacitors into the driver. Yeah, just back to the left a little. Raise those two
Oh, go
caps
up.
on the left up higher. Oh, your 25 volts is fine, but your 16 volt is a little bit close to the wind as well. And for a 0.1 mic,
Oh, yeah, yeah.
0.1 mic, 50 volts is your standard anyway, so you might as well stick a 50 in there. You're not going to, you won't pay any extra
Right.
for it. You might pay less because 50 is what everybody
Right.
uses.
Okay, so 50 volts, huh? Well,
Where
that's
was
only,
that, Ray?
that's a 10 volt thing. So 25 volts should be fine, right?
25 volts is fine, but a 0.1 mic X7R or X5R, you're going to pay more for a 25 volt than you'll pay for a 50. 50 is the standard.
Oh, gotcha. Okay.
So
50 volts.
don't think, 16's too close to the wind, but you're not going to find 16s anyway for a cheap price. You'll pay less for 50 volt because
Got it.
everyone
Okay.
uses them.
Okay. Transorb, that's what that thing was called down in the lower right. That's
Yeah,
what Reza said.
Transorb. Yeah, there's a whole pile of trademark names probably.
Did you get all that straight, Chip? There was
Yep.
a lot coming at you fast there.
There's only a few things, so let's review. The 100 volt electrolytics, what are 60 volts or whatever, those need to go to 100 volts, the electrolytics, the stuff on the main supply. Those should be 100 volts, and then we should bump up that small stuff on the gate driver supply to 50 volts. 25 would be sufficient, but 50 is cheaper. So the 16 volt needs to go to 50. I'll relay this to Michael.
Please, are you hearing me?
Yeah, yep.
Okay. Another thing, those capacitors are not aluminum electrolytic. They are, I don't remember exactly, but something like a chemo differential that withstands more wisely the voltage along the time. I don't remember exactly because we had some threads on the forum about those kind of capacitors a while ago. If anyone can remember, it's a different formulation for the chemical contents. They are not plain or raw aluminum electrolytics. They are some kind of chemical combination that can withstand for a longer time any voltage without drying off. I don't remember exactly.
But they are polarized, right?
Please, can you repeat because the
they are polarized capacitors.
Yes, polarized, okay, but they have another chemical. They are not plain aluminum electrolytic. They are called in another terms. I believe. Please,
Yeah,
go ahead. No, tantalum, no tantalum.
Polymer. Michael messaged me. He said they're polymer caps. You there, Henry? Okay, so anyway, yeah, he said Henrique is right. He said polymer caps we have, not the old style electrolytics.
Polymer or raw aluminum electrolytic caps. and also they are able to withstand with the temperature way more easily than aluminum ones does.
Okay. All right, so we should be okay there.
Yeah, Enrique needs also
polymers
a
what
better
we need.
internet connection. Enrique is fading out like you are fading out sometimes. How far it's going with your internet, satellite internet? Any news?
I think Chip's frozen too.
Yeah, he is.
See, so not.
Well, have we addressed all the questions or requests with the motor driver then? So when Chip comes
I have
back
one
from
quick
frozen state?
question, Chip.
Yep.
Chip, you said back before the design got this far that it might be a candidate to run the transformer in the project that I was doing. Is that still look to be true, or?
Could you repeat that, Brian?
Chip had said once that in addition to running the motor, that I might be able to run a transformer with this. Does that? But the design hadn't gotten this far back then when he said it. I was wondering if that still held true.
Anybody else have an answer for that?
Like we lost Chip. That's okay. I'll come back to it.
Okay.
I just want to jump in with some comments. Can I be heard?
Yes, you are.
Okay. So I would not take too much sorrow in using the electrolytic capacitors. If you look to high reliable drives, which are commonly used in the automotive industry, they all use the electrolytic capacitors. And we just have to think about what is the task of this capacitor. It has to store the reactive energy, so the energy that goes forward and backward during PWMing. And the motor's power, so the real energy the motor drives to the drives is just flowing through the lines and doesn't go to the capacitor. It's only the reactive power. And then when you brake and you feed back the energy, then the energy may charge the capacitor to a higher voltage. The question is, what dies first, the transistor or the capacitor? I fear it's the transistor. So what I would do is I would have a ceramic capacitor in parallel, because this ceramic capacitor can bring down the spikes that come from the switching. And this capacitor has to be as close as possible to the output. So in principle, they have to be exactly parallel to the power stage. And that's all. I don't think a lot can happen with this design. It's a clear, clean design, no gimmicks, and it will work, I believe. Yeah, okay.
Thanks, Rainer.
Rainer, is there any better way to handle the sensing for the EMF, or is what we're doing sufficient?
Okay, that's a very, 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 very good question. So I believe we can drive a motor without any sensing.
Without what?
Without any sensing.
Right on, that's better.
So I'm on the way to, okay, I made some sensorless motor control years ago with the Propeller one. But then I slowed down with this and had to do a lot of different things. Now I'm coming back because I have done motor control tasks. And So what, on the other hand, I really, really want to do is I want to learn and to use Tachyon, because Ford is just such a great thing. Unhappily, Peter is not here. So yeah, he went a bit aside, and I hope he will be back again, because I think motor control is a very important task, and I will give some examples and some guidance to do motor control efficiently using Tachyon or Force with the Propeller 2. So what I have written for the P1, everything is in, or mostly in assembler, some spin, but the technology can be transferred to the P2, and it will turn out it is very, very easy to drive a motor. Indeed, it is impossible not to drive a motor. So what I say is, imagine the motor draws a certain current, and you apply a certain voltage. Then it means you transfer some energy to the power stage and to the motor. If the motor doesn't work, so if you do not control the motor properly, he cannot run. That is, he doesn't give energy to the wheel, but you feed in the energy, and the energy has to be somewhere, and it only can be stored in the inductance of the motor. So immediately the current will rise, and extremely. And then when you see the current rises, you PWM backward, so the current comes back, and the current again charges the capacitor. So if you measure the ripple of the capacitor, then you can determine if the motor is controlled properly. And if it once is controlled properly, you just have to take care that you don't lose control. And that's the whole secret. It's so simple.
Wait, you just have to take care that what?
Yeah. So if the motor runs and you do not control the motor properly, within milliseconds, you will completely desynchronize. And if you are not able to detect this, so if you are not able to detect that the energy is coming back, what again charges the capacitor, then you do something wrong. So it will turn out it is extremely simple. We only have to realize it. And the propeller is the perfect chip. Just to give a short explanation. If you apply a constant voltage to the motor, what you actually do with PWM, you apply whether the full voltage or zero, or you inverse the voltage. So if you apply constant voltage to the motor and you integrate the current over this very, very short period of time, so during the PWM cycle, the integrated current is the charge you brought to the motor, and charge time voltage is energy. And energy divided by time is the power. So with every PWM cycle, you have to bring the same power to the motor, and during the reversing phase of the PWM, so during the zero phase, this energy partly comes back, and you can measure with help of the propeller all 6 states. You can imagine that the motor runs with the integrating ADC. Very, very simple. It's extremely simple. So it will be a big surprise, and I bring this knowledge to the forum just to support Tachyon and the efforts of Parallax, and to honor Chip and to show my knowledge. Okay, but that's another thing. Yeah. So I think that will be a very interesting time. So bring this thing, build it, sell it. I will try to make some P2 D2 boards. So I will try to start production of these boards. And I hope Peter will help. And maybe, Peter, you are watching. Please come back. We need you. Okay, that's what I have to say to this.
Okay, Rainer, thanks for that. So what I glean from that is that what we might be able to do if we want to know what the current is, we could just use that single sense point through the 50 milliohm resistor during the active PWM phase.
Yes, that's sure. You just read in the P1, you just read the counter every time you switch. And then you have exactly the values you need. That's so simple. And it cannot be done by a sampling ADC. Using sampling ADC is high resolution, very fast and exact timing. That's complete nonsense. It's incredible. It's incredible. You can see things you never saw.
Oh, so you're saying that an integrating ADC like a delta sigma is a better type for this?
You cannot imagine something better. It's just what you do. You measure the current, you measure the charge. You measure the charge, and charge times voltage is energy. And in the end, energy is what you have to pay for. We are not interested in voltage. I don't care about voltage or current. I just want to drive my motor.
So, and you basically say when you are measuring inside of a PWM frame the returning current, and that current gets out of bound, you lost control over the motor.
Right.
Yeah. And then you go back and get the it's a nice idea. I like it.
Yes. And it works.
Well, there you have it, Chip, from the corner of the world that makes all the best machinery.
Right, that's what I'm thinking these guys understand. And to me, yeah, this stuff is always a little mysterious. So Rainer always passes me the football, but it seems to turn to antimatter before I catch it. Because it's so simple to him that it's elusive to me. I can't quite get my head around it. But I understand this matter of counting charge, and that's energy.
Yeah. Yeah.
Well, he's available, it sounds like, when we get to the firmware state of this, and we have the hardware designed, so we're on our way.
Yeah, but there we have the problem that he wants to use tachyon, and I like it very much, but it doesn't really. I tried to combine running force and other software written in other languages at the same time. And force, like Peter did it, needs the first 64, 128K. So it's kind of difficult to combine it with kind of running in spin. I had to do something like Chip does with his debug loader, that I basically relocate the spin code and put the tachyon block before it as file. And it's kind of difficult to get tachyon working together with other programs. It's doable. You can basically, tachyon can uses a serial input for kind of, but the funny thing on force is that you can redirect input and output to any other fucking device. So I did it to a mailbox with Peter's help, and basically I could send out of spin text strings to tachyon to execute. So basically using tachyon as a module in a kind of, you know, and then it makes a lot of sense in my opinion, because tachyon is, or force itself, basically is a user-defined language. You define words and you write your own language for your whatever you write, you know.
Exactly.
And that is what the funny thing on force is, and that then basically you can use a kind of modified serial object, and out of C or basic or spin, you just call that thing with a string and you get the results back. I mean, it's perfectly nice if it's running, and I had it running, but it was on REF-R board, so now I have to kind of redo all this. But basically it's working, and you include kind of the whole tachyon as a file in the spin object, and then you have to kind of poke around in memory to allow it to work, sort of. There's somewhere a thread, I don't know, that Peter helped me about that, how to redirect the input-output to mailboxes. And then it's basically usable like any other object in spin.
So one advantage of Peter being busy in a different way is that he doesn't change tachyon on the fly. So it's
It's a funny, good thing. Yeah, I have to fight with that also. Yeah.
So it's stable. It's stable now, and as you said, Michael, it's your own language. So we have to define the words to control motors, or commutate, or find this, determine cosine phi, and so on and so on. So.
But on the other hand, if you have that in P1 spin and P1 assembly, shouldn't it be easier to just run that through, I don't know, FlexProp can compile P1 spin to P2, and okay, the assembler part you have to rewrite, but wouldn't that be an easier thing? And then we had it available for all languages except tachyon.
The point is, if you gain experience over your lifetime, sometimes you have to throw away everything and start from fresh. So as if you had all the time in the world. So you start from fresh. Throw away everything you know. Just take the basic idea and do it. And tachyon, or so what I worked with a transputer. One chip was about 1,000 Deutschmarks, single chip, and you had something like a virtual parallel processing machine, and it's a very good principle, this language, to have a data flow machine that is very good. But when it comes to reality, the moment you start 1,000 tasks, it doesn't run anymore. So the principle is okay, but when it comes to reality, it's more or less academic. And then I had to give up, as the transputer just was canceled. And for some reason, I found the P1, and I realized my dream became true. I could start a new life. And the P1, and now there's a P2. Sure, you can transfer what I have done with the P1. So you may, it makes sense to see the assembler code, but I have to tell, when I start over again, I do not understand what I wrote. It's so difficult to make the PWM, to synchronize the processes, and to remember all the. Yes, okay.
Okay, I have to disagree there, because I think rereading source code you wrote 2 years or 3 years ago is more difficult than rereading spin. In my opinion, I mean, I like force, the concept, and I like tachyon very much. Don't misunderstand me there. It's extremely fast, and Peter did a very good job there. But it's a write-only language, basically.
Yeah, write it once and do it right. Then the only. So yeah, there is no need. There is no need to change any operator of the P2. The P2 is created. Okay, it exists. Now you only have to understand what to do with it, and the same has to be with the language. You should not always invent a program again. Use modules, use words, and that is what tachyon allows, or Forth allows.
Yeah, that's right. Yeah. But I'm still thinking about your sensing. So you're basically sensing the misalignment of the motor by the EMFs, the back feeding current, sort of. Kind of like the motor is stalling and that the current goes up, and that's the reason why you have to pull down your PWM again.
Yes.
So I mean, and you do that for every PWM step, so you're kind of
For every
all the time in between.
okay,
Yeah.
for every switching cycle of the PWM. Yeah.
Yeah.
So,
So you catch kind of any mismatch current, or in that case energy. You catch the mismatch and then react on it on every single cycle.
yeah.
Sort of. Yeah. Okay, that makes sense.
Okay, I will see what I have here. So I was not prepared to present it now, but
yeah, we have to milk out the knowledge.
for some reason I do not find the pictures I normally. Just a moment. Oop. Okay.
Because to me that makes perfect sense, and with a P2 we can kind of attach pins to each other, so we can measure with a second smart pin while we have. I mean, it sounds like it's exactly what we need to do.
I think what Reiner is saying is, I don't think he even looks at the EMF, but he would monitor current. You could take many, many short-term readings and have kind of like a moving boxcar system, and then keep a running average at all times so that you could compose a sample of any phase relative to the PWM. So it becomes very liquid. I suppose he would do something like that.
I think so, yeah, and it's an interesting idea. I mean,
So
I can imagine if it runs fast enough, it works. I mean, yeah.
I just switch over to my other monitor and let me see. I'm mostly controlled brushless DC motors, and this is what you can see. What people say it's a back EMF. So this signal you see at the virtual start point when the motor is running, and with the propeller, you can extract such signals, or this, or that, or those signals. So you see here in different colors, you see different states in the motor, and all these signals are derived from this garbage here. So normally people try to filter away all the spikes, but what indeed they do, they destroy all the information that is contained in the spikes, and in the spikes is all these information. So here you can see how the signals change when the sorry, I have to see here. You can see how the signal changes when the phase is not correct. Yeah. So I made many experiments. Oop, that was different. So I will share more of this in the forum, and I will give a link to a source where you can reread everything. So, okay.
Thanks, Reiner.
Yeah, that's just too much now.
You should do an own presentation about this.
Yes, it's years of work. So,
well, you've been a fabulous supporter of propellers and talking about motors for, I think, 20 years with us. So Thanks for doing that.
Yeah.
Well, can we move on then beyond the BLDC controller? All right.
Something kind of funny and light but short. You might have, or Ken, were you going to say something? Were you gonna
No,
talk?
go ahead. I just
Let me-
have some other items that we can hit them, knock them off in any time.
My old friend sent me something that I had forgotten about, but he somehow had it. Let me share a portion of my screen. This is from like 15 years ago when we finished the Propeller 1. We had this artist do these graphics for us. Where, can you guys see the doggy on the bicycle? So this was kind of in the form of like P.D. Eastman's Go Dog Go. I don't know if you've ever seen that children's book, real fun book. So here's how it used to be when everyone first had microcontrollers, right? It was a lot of fun. Then you could, you had a lot of freedom. You could stand on the seat, put one leg in the air. You could do all kinds of things. We had another one where the dog had the bicycle like turned upside down and he's sitting on the curb and he's turning the crank, watching the back wheel spin in the air. Lots of stuff you could do with microcontrollers. Then it morphed into something like this. and we don't have the resolution to see here, but he's dragging the kitchen sink and he's all strapped in and he has a helmet on. And there's this panel here that says no peek, can't look inside. And then he has this screen in front of him and it has all these things, these check boxes, and he has to check. It says, I agree, I agree, I agree.
That dog has lost all enthusiasm too.
Yeah, look at him. He's like slumped in the chair.
He's given up.
Yep, yep. This is how a lot of things have become. So then then we have the final frame of like what the propeller chip is like. So now instead of wheels, you're like airborne, flying around, lots of freedom. You can go up in the clouds. Anyway, that's that. We had a lot.
Okay, I have one more question for Ken. That motor control board is basically now for one of those wheels, or can you run two of them?
Two.
And second, this board needs a P2 edge also, right?
Yeah, it looks like it'll connect to the Johnny Mac board or the mini breakout board or the demo board.
Yeah,
so
now the basic question is, if you want to build a hoverboard, you need two wheel kits, so 4 wheels, and can you drive them with one P2 edge, or do you need two P2 edges for each wheel set?
Well, this is designed for one P2 edge.
Yeah.
So I'm sure we could drive many more motors. Couldn't we, Chip? Have you figured that out?
Well, you mean how many of these you could use at once?
Yeah, it looks like you can connect 4 of those to like a Johnny Mac board, for example.
Well, let's see, each one takes 2 ports. I'd say 3 would be the limit.
3 pairs, meaning 6 motors?
That would run, well, okay, well, let's see, each one gives you 4 half bridges and you need 3, right? So 3 boards times 4 would be 12. You could run 4 brushless DC motors on 3 boards. But the reason we can't run 4 boards is because those upper pins get used for the programming and download and all that.
Yeah.
So that's the only problem. But
you could run 3 boards, so 4 motors with one P2 edge.
Yes.
Yeah. Good. Yeah. Okay. Yeah, then it's fine, because I will need 4-wheel drives.
Yeah, and if we can do what Reiner's talking about and not need to check every EMF signal, then we could reduce things quite a bit.
And it should be pointed out too, Chip, this is the first of a couple of boards like this we'll make. This is really the development tool for all of us to work with. And the one I'm really enthused about is more the end result, which is a standalone P2 Edge general purpose BLDC motor controller for the Arduino users and the whoever, Basic Stamp, everybody else, Raspberry Pi with some kind of serial control.
Yeah, well, then Rainer Nase comes in again, because serial protocol would be effing easy with Tachyon.
Mhm.
It's just a control language you send down, and good. You
Good.
don't have to program the P2 at all.
Well, this is fun. I'm glad everyone's interested in this. It's inspiring.
Yeah, but in this case, Rainer, are you still listening?
Yeah, sure.
Yeah. In this case, you should restrict yourself to the ROM tachyon and not or to tacos and not the reloaded one, because that is existing in the ROM. And if you provide every other word, then you are fine, and you don't need that dependency on Peter changing tacos reloaded every couple of days. Not now, but basically he does. If you could provide starting tacos from the ROM and then add what you need on words, that might be the better solution. So you basically take tacos reloaded out of the picture, and the ROM will stay the same.
That's definitely right. That's one of the big advantages of Tachyon, that even from the ROM, you can load the ROM to the ROM, and then you can change or add words and can store them.
Exactly. Yeah. But if you start with a ROM and then add your words instead of starting with tacos reloaded,
yeah, sure.
You basically are sure that you have all together.
Yeah, sure.
Yeah, that's my thinking.
Okay.
But I like the idea. I like the idea because I understand tacos that much, or force that much, that I just can't program it. I don't like it. I can't do that jump. But I like the concept, you know. Yeah.
I just want to share this picture. I found it.
Mm-hmm.
So this is the output from measuring the current at a single shunt. When I control the motor, that way I have an incremental encoder connected to the motor, so I can measure the motor's position.
Yeah.
And then intentionally I run the motor in different phase angles. So I turn the motor around without turning the field, so the motor creates torque, and then it brakes, and then it's balanced again. So I just look what are the different conditions of the motor, and then you see that there's a circle. This circle is generated from the current, and then you see the spokes of this circle. The spokes are different currents, different current values, and if you want to control the motor, you just have to take care that this single spoke is kept. So you just measure the signals and take care that this spoke exists and not the other ones. And then the motor is controlled.
Yeah, yeah. I mean, it's that's what
really fun.
Yeah, I like it very much. I like it very much. What do you use for visualization of that stuff?
That's Ariba's simple terminal, a simple graphic terminal. So the graphic is calculated in the Propeller.
Yeah.
It's just a simple graphic terminal from Ariba.
Yeah.
Opterm, glaube.
So kind of saving a BMP file on you kind of.
It's
but you generate it on the Propeller.
Everything. Yeah. The graphic come from the Propeller. Cool. It's just the internal. It's a very, very early stage of debug.
Yeah.
Of chips debug windows. Now with debugging, that creates such signals is much, much easier. Yeah.
Okay, so let's move on. Peter, you have your hand up, or is it a particular question, or?
Yeah, if you don't mind, thanks for the opportunity. Yeah. Thanks for today's discussion. It seems to be a little far ranging, and I appreciate that, Ken, you were trying to move away from the motors. So I'm, I'm relatively new to the parallax world, although I did make a serious effort 3 or 4 years ago with the original P1 to do some work around what I'm working on, which is mostly electric vehicles. And I've finally decided it's time to get back to that, especially with the P2. And my question is very simple. So with the P2 Edge and the P2 Edge daughter board, or whatever you call that, and I'm also have quite a bit of experience. Well, I have a lot of experience in Arduino and ESP and all that stuff. And so your ESP Wi-Fi board, connecting that to a P2 Edge daughter board. I've also got on order the P2 to the click conversion thing, because I've also.
Okay, there's several questions in there when he comes back. So who would like to answer for him the Wi-Fi question? I didn't hear exactly what it is yet, but
with the P2 evaluation board that came out originally.
You froze for a little bit there after the you mentioned the Wi-Fi module with the ESP part on it, and then you went static.
Oh, I see. So the ESP module, what I'm trying to do is get myself tooled up for the fall here with the P2 Edge, the proto board, and the click adapter board, and just thinking about that ESP Wi-Fi SIP device that you have. Is that compatible with that P2 Edge product in some way through those pieces?
I can answer that, or someone else can who's more familiar with it. I think the short answer is yes. We have some firmware that goes into that WX module that we've written, and I don't think we've produced any examples yet with the P2. I might be wrong, but I know where you can look to model some examples, and that would be on the probably in the spin 1 or in the C examples that we have on learn.parallax.com. If you get my junk mail, then you send me a message, I could get those links for you.
And there
okay, well, I'll do that.
There is some adapter for your Wi-Fi module which adapts the footprint. It's a small breakout board which sits on the headers of the evaluation board. And the ref C is already programmable with that Wi-Fi module. And you have that Wi-Fi module as is, and there is a small adapter board in your list of things which kind of connects that to the P2 evaluation board headers. So that basically everything is there. You should be able to connect, to just plug it in. You need to get that Wi-Fi module and that small adapter board to the P2 eval. And the ref C ones, the last eval boards, they can even be programmed because there's some change in the receipt line. Ref A and ref B can just use it as serial module, kind of like a serial module. But the Parallax already has them parts. Also, that small adapter board to plug between the SIP thing and the eval board header. I'm not sure about the Edge.
And I put the link to the adapter board in the chat. It's part number 64008. They're $5. And you mentioned you bought the SIP. I think you should get the DIP module to plug into this board.
Okay.
So, wait a minute. Do I have that right?
For those answers, I just want to make a note. You know, I've refrained from getting into the P2 just because I'm in Canada, and shipping to Canada has become just brutal for almost everything. You're not the only ones that it just makes it inaccessible to acquire a hardware from the US. But I'll just note that you've set up DigiKey to be able to provide your product. And I'm able to buy that now through DigiKey, all of the Parallax products through DigiKey with completely negligible shipping. So really appreciate that, having that opportunity in a much more affordable way.
Really good to hear.
Yeah.
Thanks.
Well, thanks for the tips. It sounds like I'm going in the right direction. So
yeah, I think my view of what's lacking is just examples. So the hardware electrically and signal, everything can work, but I don't think we have a lot of examples. You'll see I've also posted a forum thread around the same idea as you're discussing before, I don't know, mid-June with big plans, but I didn't get to it because work got in the way.
Yeah, well, that's a common story. Big plans, things getting in the way. I just wanted to mention that, back in the Z8000 days, of those of you that remember those days, I was trying to build parallel processors back then based upon that hardware and some Intel multi-bus hardware. And so it's a nice return for me to come back to the Parallax product, which is essentially the idea I had back then with inadequate resources in Canada. So thanks.
Awesome. Good to have you back. I provided the wrong part number to him as well for the WX adapter. I don't know if somebody else can find that on our site.
Yeah, the DigiKey site is often difficult to navigate. They don't have all your products listed in one place under your Parallax heading. Sometimes it's under different areas. So it's a challenge to find things that, although they seem to have everything in stock, which is fantastic, given what you're indicating about chip shortfalls.
Here's the link, actually. It's 64007.
Oh, yeah. So I've got that piece on order. So that's the piece I've got coming.
Yeah, you have the right part, not the dip, but the SIP version. Cool.
Okay, that's great, because I've got that part on order from DigiKey. Thanks.
All right. So Chip, Mike Green's been patiently waiting. He had a question in the beginning about how interfacing push buttons with 9 to 12 volt pull-ups might be done with the P2.
So let's see. So in other words, you push the button down and it goes to ground. You let the button up and it goes to 9 or 12 volts. Is that right?
Yeah, and on the P1, you just need an adequately high series resistor. And
Same thing.
Okay, is there a difference in the protection diode? In other words, I need to limit.
It has clamping diodes on both chips.
Oh, okay. That was really the main question.
Well, we had to make you wait an hour and a half for that one. Sorry, Mike.
I learned all kinds of interesting things.
I figured if you needed it answered quickly, you would have said something.
Yeah, basically we should all Yahoo or something like that. That Mike is working on a P2 now.
Right.
I love this stuff with a basic stamp, and now he is coming to wow. I like it.
Yeah, he's among the.
Actually started with a BS1.
Mm.
So
Mike has so much patience and answers so many questions on the forum for so many people too. So
Yeah,
Chip, another item.
Okay.
Maybe we could address since Eric is here and Michael brought it up, clock mode, clock freaking compatibilities, memory locations between your compiler and others.
Oh, yeah. Okay, so.
You know about this?
Yeah. Yeah, this is.
Is this a big topic?
Well, yeah. Okay, so the problem is that I put my clock mode and clock freaking in one place that was kind of like sympathetic to how spin lays out in memory. And then a precedent had been set though by Tacos where he put it in some other place. So
actually not just Tacos, all the other ones, Ross with Catalina, P2 assembler, all of them have the same address. Just you are kind of.
All right, so tell me quick. There's two things. There's clock mode, clock freak, right? So
exactly, and Eric can tell you where he is saving it, or all the other. I mean, all of them agreed to use one memory location, and you have a different one for both values. It's too long, and you can probably move them in your interpreter to something else. I hope it would make things easier. I mean, even says that the glitch is not appearing much, but basically you need to have the old clock frequency to switch back to RC fast. You have to kind of need the old setting and then delete the last two bits to 0 and then set Z and then set RC fast, else you kind of can hang. That's basically the problem with clock switching. So you need the old values basically if you want to do that while the program is running.
So what are the, maybe if Eric can remember, or whoever remembers, I think I put ClkFreq at 10 and maybe clock mode at 14 hex, but where do you guys put them?
I think it's 40 and 44 or something. Eric has to
other way around, I think. I think, Chip, you've put yours up at 40.
Yeah,
and we put ours.
I put ClkFreq at 40, right?
I'm not sure which went at 40 and which went at 44.
I'm going to pull it out just so I can see. Oh, okay. I put at 40, I put the clock mode value, and at 44, I put the ClkFreq value. Those are byte addresses. I was thinking long addresses, long indexes. But so these are the byte offsets: 40 for clock mode and 44 for ClkFreq.
Okay, I think TACOS and FlexSpin and I think everything else does 18 for hex for clock mode and 14 hex for clock frequency.
Yeah, okay, that's right. Yeah, what I did, I left 0 through 3F as completely unused locations that could be kind of like for whatever the customer wanted. Yes, so these are located right in the middle.
Well, you could,
I mean, I could.
You should just do it, please.
What could we? Yes, well, that would be.
we could leave 20 to 60 is free for the customer.
Yeah, we could put it at 20 to 60. Okay. So what I'm not, okay, one thing I've never all the way gotten my head around, which has been one of my impediments in all this, is that if you're running spin, how are you also running anything else? Can you just give me a practical example? Like, are you thinking?
You could run something else in another cog.
I give you a perfect example, Chip. I have running a benchtop software, a benchtop P2 appliance, and I have 3 different programs I would like to run on it. Sometimes a logic analyzer, sometimes whatever. And they are written in different tools. One is written in Catalina, one is written in FlexSpin, one is written in spin tools. They have to load each other. They have to reset the clock to RC fast, and they can't. That's basically because I can't find the old value because I don't know what is actually running now. I mean, that there is a problem in my opinion. If we stay on the same locations, any tool can like here, Cluso 1990 with his small oscillator, or Jim Godpaster here with his four screen. He needs to load different programs, games. He has just a small list and select the game, but that can be written in Spin, or can be written in C, or can be written in Catalina, and he has to switch back to RC fast before to load the other.
But cannot.
And he needs the old values, or it glitches.
Right.
Where it goes isn't really a big deal. I mean, I could easily change it in mine too. The thing is that TACOS is in ROM, so we can't change that. And that
Yeah,
does have it.
everybody else does it too. You does it, Catalina does it, P2 assembler, whatever it's called, does it. MicroPython, all of them use the same location except chip.
Right. All right. Okay. I want to say I'll just do it. I've gone there a couple times, but then I don't like the disturbance that it causes the memory map. But if it really makes a difference to people, I could do it.
Chip, it sounds like you've already lost on this one, I hate to say, because all these other tools are using the same.
Right.
Strangely, our biggest customer with the P2 is using Forth. I wonder if he fits into that situation too.
Yeah, the fourth, at least the fourth in ROM uses that location, the 14 and 18 hex. That's why we chose it, because we thought, okay, this is in the ROM. We better be compatible because we can't change it.
Those are like the 6th and 7th longs in memory, right?
Yeah, yeah.
I wonder why.
He actually uses at 10 hex, he's got the crystal frequency, which I guess he must figure out. So 10 is the crystal, 14 is the CPU frequency, 18 is the clock mode, and then at 1C, he's got a baud rate.
He's got a what there?
The baud, serial baud rate.
Oh, baud, okay.
Now, I don't know if anyone else uses those. The 14 and 18 are pretty widely used.
Right.
And 10 would be kind of nice to have, but that's, I don't know how we standardize on that. That's hardware dependent.
I think it wound up, okay, so he starts at the 5th long because he probably had some little code stub in the first 4 longs, right?
Yeah.
That initially these things to where they wound up.
That would be my guess, yeah.
Chip, are you going to enact this change? And when you do, what is it? What are the ramifications for people?
Well, within Spin, this is all symbolically accessed. So it should be transparent. You know, everything should compile for customers as it has. I do in the documentation, I think I mentioned that these things are hard placed where they are.
It's possible that 1 or 2 objects use the hard-coded instead of the symbols, which they shouldn't, and maybe this is a good time to get them to change.
Yeah, and I don't know.
Yeah.
Whose objects would do, I don't think I've written anything like that. All mine are using the labels that are built into Spin too.
Yeah, they should. That's why they're there. But I seem to remember someone on the forums asking about it and saying that they were using $1.40. But maybe they fixed it because people did point out that there was a symbol for it.
Mm-hmm.
Well, since Eric is here and we have a lot of FlexProp users, are there any wild requests for Eric? I'm sure we'll gladly entertain them all.
Sure can.
Yeah. And if you're using FlexProp, consider joining his Patreon. I pasted the link in the chat. This is important so we can move him from volunteer work to productive work.
Thanks, Ken.
You bet.
So the big news in the FlexProp world right now is Ada Verfo 21 has contributed a bytecode port. So we can now compile BASIC and C programs to run on the P1 ROM spin interpreter. And eventually we hope to get it working with P2 bytecodes as well. So you have the choice at compile time to either compile PASM for speed or the bytecode for smaller size.
One thing I see about that in the future is, am I going to get like stuck with because sometimes I just change stuff around because I realize it's more efficient to do something a different way, because I'm the only one that does spin tooth bytecode. So
Oh, the bytecode is linked with the program, so you know we can. You're not stuck with it like we are in ROM.
yeah, I mean, it could generate. Would you bother making the same bytecodes I do, or would you just abstract it and do your own set?
I'm actually a little bit tempted. I've been thinking it would be cool to be able to customize the interpreter for the application. So I'm actually looking at that to see, because you know some bytecodes wouldn't even be used by some applications.
Totally,
so it'd be nice to. So I'm looking at that.
I'm in support of you doing that so that we don't end up with issues where it's like I change something and I break your tool, you know, or you do something that the way it gets done and then I, you know, I don't like it for some reason.
Sure. No, and it's okay if we diverge because it's linked with the program. So, you know, what Peanut does doesn't have to be the same as what FlexSpin does. With the P1, we're kind of stuck with
based on what the.
Yeah,
you're stuck. But if you do your own, you could actually allocate the bytecodes for what is needed, like give them the most efficient single byte codes so that you don't necessarily, like I have some things that are just 2 byte codes, right? But if I had a super smart compiler, I could, like looking at the entire application, maybe reduce most applications to using single byte codes only, which you could do because that's how your tools work.
That's what I hope to be able to do. Yeah.
And that'd be neat. But you could make, you know, more compact code than I would.
We'll see how it works out. Probably start with something that's very similar to what you've already got.
Yeah.
Well, should we talk about floating point progress, Chip?
Yeah, there's not much to say. I was cruising along and then I absorbed all of what Eric told me about the NAN, not a number business. And then I went off to this girls' camp and cooked for a week. And I spent I have not been very productive lately. I've got my office cleaned up. Because it was a total pigsty. Ken was telling me about hoarders and I was actually like a level 2.5 hoarder, but I'm back down to like a level 0 now. So I spent a lot of time just reorganizing, you know, where I work.
Well, you're an interesting rehab because there's like a 95% chance hoarders do not become unhoarders.
Well, I recognized it was a problem. I just had this accumulation that had built over like 13 years. There's even stuff that was from 30 years ago that was piling up and taking space. So I took many, many things to the dump and I threw away a lot of parallax history just because I didn't have a place to put it. You know, I threw away a lot of original P1 chips and that were in special packages. I just didn't want to hold on to it forever. So now I'm just down to, you know, the essentials.
Can you make a camera sweep around your office now? The last time it was kind of crowded.
Yeah, show us what's up. That's a good idea.
Exactly.
This is my little messy corner right here. See, I've got these boxes, but they're in boxes now. It's not all over. And I got rid of like 2-3 pieces of furniture that were just forming like, you know, surfaces that junk and dust were collecting on. So I put the drum kit over here. There's the door. Now there's some junk there. I got one of my old big TVs and a table that we use for kitting. And then I got everything dusted off. So I got the stereo. There's a HEPA air filter that keeps everything clean. Let me turn around this way again. So we're back here, and then here's my desk. See, very little stuff on it. There you guys. And then here's some equipment. And I've got a lot of stuff in boxes up above the roof here that I may need in the future, but don't need right now. But it's good to have a clean workspace because this thing had been.
Compared to the last pictures you sent, it's very nice now. Yeah, the floor is empty.
Oh yeah, there's no dust. I mean, I pulled furniture away and there were blobs of like brown cobwebs that you couldn't see through this big. you know, there were dust and rocks because I tracked gravel in from outside, and everything is like inside of a clean house now. And I bought a new vacuum cleaner that I clean the office with. Anyway, so that's in lieu of floating point progress. So the floating point was moving along, and then I realized I need to do the NAND stuff, and that kind of threw a wrench into things, and it was like, it was enough disturbance that I finished cleaning everything.
So let's cut a deal then, because this can't go on forever. How about you send 2 kids to my house for a week, and then you finish floating point by the 4th of August.
Yeah, I could have it done in it. Well, I could have the basics done in just 3 solid days of work, I think. And I've been looking over all of Eric's stuff. Eric has like super comprehensive floating point stuff and his compiler. In fact, the source is all in spin, right, Eric?
Yeah, well, actually, the version in the compiler is a little bit different than the spin object. I tried to clean it up and make it look better for what I put in the OBX.
Yeah, it looks really good.
So Chip, is that a yes? You think you could have it ready first week of August?
Mhm.
Okay, and if you finish it, I'll give you your kids back.
How long would it take to get it down to Propeller tool after that point?
Not long. Once it works in Peanut and I document it, Jeff just has to do a compile, and it should. I don't think this creates any big change for him. I think it's just another compile and inclusion into his app.
Dan?
So a day or two.
Oh, yeah, hi, Carol.
Hi. Did anybody, this is off subject a little bit, but it's hard to get a foot in here. Has anybody come up yet with an idea on accessing the Cogs in the parallax chip through the MicroBit?
Oh, you're still working on that. Okay.
Well, I'm going back to working on it. I had a
Yeah.
small stroke several weeks ago, and
Oh, no.
that's why I've been offline and haven't sent you the completed bots yet.
Okay. I'm glad you're here. No, I think you're the main person driving that, and nobody's touched that firmware, which is what needs to be done. So she's talking about the cyberboard on the Cyberbot, which has a Propeller 1 on it, and she wants to get out of the box and get better multi-core control over the robot than was originally intended, so it can sing and dance and flap wings. So no, unfortunately, we haven't done anything, but I send you the firmware, and I think it's available on our site. I don't know how far you want to get into that.
Yeah, the firmware is available on the site.
If you, maybe we need to go back and visit your problem again, because I thought we almost sorted it out, didn't we?
No, I'm still stuck with the bit of trying to make the MicroBot multitask, which it isn't very good at.
Yeah.
You know, using just programming, but it just hasn't got those capabilities very well. But if I could access the Cogs through the interface on the P1, then I could have it do the multitasking, because it's easy with the Cogs. Because I want it to flap its wings, make a noise, and use the ping and everything all at the same time. That's the only way to make it look like a natural bug.
So it's those motors, they think, that are the issue in the sound, right? Together.
Yeah.
Okay, I'll make an official request of Andy. I remember how things work well enough to describe it to him. So hold me to this. Ask me in a few more days.
Okay, I'll take a look at the firmware. I didn't think of doing that.
Might help. It was written in C.
Programming skills may not be quite up to that level, but I have done some stuff like that.
So, you know, really what that firmware is an adaptation of the closed loop motor controller, plus a lot of other functions added into it from the original activity bot. So it's kind of modularly written, and I don't think it would be too difficult to expand on. but I don't know how many resources are left in it either.
Okay.
We'll find out.
Yeah, I'll look at.
And welcome back.
Yeah,
Yeah,
I finished all my physical therapy. The only problem I have right now is a little bit with my left hand. It was just a small stroke, but that's God, it's a nightmare.
I'm sure going to the hospital wasn't something you envisioned after the past year and a half either.
No, because the whole time I'm in there, Bill and my daughter and grandkid can't visit me. So it's, you know, you get pretty freaking lonely.
Mhm. Well, had we known, we would have sent some hardware. We recently sent some hardware to another customer who does special effects who was in the hospital. I didn't hear if he got it. We had to, he had a more serious situation. So we're trying to get his head around the P2 in the mix of recovery, which is probably difficult.
Yeah, no, mine was just a light problem. They got me to the hospital quick enough that they gave me that shot that reverses them.
Mm-hmm.
Doesn't reverse it 100% though.
Yeah, well, that's why you have a Corvette in your family. Fast transit to the hospital.
Oh no, Bill's in love with that tractor even more than the Corvette. He's always digging up stuff to do with it. He's helping out the neighbors if they need a stump pulled or blackberry bushes mowed down or stuff like that. I'll do it. Puts on his John Deere hat and out he goes.
I can understand that part, honestly. I would like to have one of those tractors. But getting you to a hospital, he honestly should take the car.
No, actually, I went with flashing lights and siren. Which that part's kind of fun. I wish they'd medevac me. Geez, I could ride in a helicopter. Set me up where I can see out the window.
A room with a view.
Yeah. So that's my question, and I will go back to quiet now so you guys can cuss and discuss the next thing.
So basically, you need to access other Cogs from MicroPython that just one of them currently, right?
Well, sort of. It's this kind of situation. So she's actually using this product.
Yeah.
And it has a MicroBit, and underneath this board, we have a Propeller 1 as a coprocessor.
Yeah.
So it's a kind of a static firmware without a programming port on the board. Actually, they're just four little pads where you can put a prop plug in, but she's a pro user.
Really nice with a gripper on front.
Oh, it's super nice.
Thing, huh? Super nice.
Yeah, I've got one with a gripper on the front, and that's an alligator. I turn the gripper sideways. So that's an alligator, and then the other one is a bug with flapping wings and flashing eyes and stuff like that.
And speaking of grippers, we only have a couple in stock, and we're going to be out of stock for a long time, unfortunately, as we move machines around.
And screen printing teeth for it.
But so basically, Michael, Carol's used to using Propeller 1 with FlexProp and having total control over everything. So we've got her doing some projects on this to share with customers because everybody loves the things that move and flap wings and make sound.
Mm.
So she's just a little short on resources and she's out of bounds with the product. So
yeah, but I follow Carol a lot, and I mean I even follow her YouTube thing because she she has funny ideas, honestly. I mean, she puts some fun into programming.
You know that the spider, then you've seen it. I've got another one now that's just about 3 times the size of the other spider. I think you can see it up in the corner of my workroom if I turn my computer here. Where'd it go? It's sitting up there with its legs folded up. Is that it? Is that it? Up here. Yeah.
Oh, Carol, you are the greatest, honestly.
Bring one of the legs down. Can you see the size of that?
That's a large robot.
That's a
Yeah,
lot
it
of
is.
fun. I like it.
It stands about 2 feet high. And with the legs all spread out, it's about 3 feet across. Ow. And it's hard to use. All right. And I'm back to normal. But that's not a parallax thing, so I don't advertise it too much.
Oh, it's still cool. You can do that anytime. We don't own any copyrights on creativity and fun.
Hey,
So we got
Carol,
any, yep, Chip.
Carol, I sent you a little question. Maybe you can answer it. I just put it in the chat here. And hey, let's see. Where did it go? Eric, you were talking about the looping. I changed the interpreter so that in a repeat loop where you're using a variable as the count, it winds up with the last value at the terminus, not the one, you know, beyond where it should have stopped.
Ah, okay.
I made that change, but I don't know if it's pushed all the way to like prop tool yet.
Wow, I've never heard of that. I just read your thing, Chip.
Oh,
The doctors didn't mention anything like that. And I have both my COVID shots. And this happened after.
yeah.
I'll be damned.
I had asked Carol, I didn't want to open a big discussion about it, but I'd asked Carol what the nature of the stroke was, because they're finding that a lot of the shot recipients that are generating the spike proteins now, these things are causing micro blood clots that don't show up under normal tests. There's a D-dimer test that can detect this, but it blocks the smallest capillaries. So I'm wondering if that happened to Carol. And then the big question is, does this spike protein mechanism fade away over time and go dormant, or does it just escalate in perpetuity, which would be a terminal problem?
I was wondering why I even had one since I'm on warfarin.
Yeah.
And that was one of the things that threw me. I thought I was safe from blood clots.
Well, you can request this D-dimer blood test and they can maybe come up with something. It detects microclots.
I never heard of microclots, and the doctor certainly didn't say anything about it.
Yeah, this is all like not on the mainstream media. You never hear about this stuff on the news, but it's available on the internet if you search it.
Okay, all right, I'm going to check into that.
So we have to get Chip on the road towards parallax in 15 minutes.
Huh.
So any other topics of interest to people that have not been brought up?
I got to show one quick thing. See my office? This is cool. I used to have so much dust. Can you see down here on the floor? All these cables, big mess. So I just did what I used to do when I was young and energetic. I tied all the cables to the top of my table here. And now there's nothing on the floor to make a mess again.
That brings up a question. Ken, in your office at Parallax, you have power strips that run along the middle of the wall. Where do you get those?
Those from the supply house around the corner. There's a name brand for them. Let me think of it. I could just go check one. And I think Peter's got his hand up too. So let me go check it on that. Peter, what's up?
Yeah, so see, the other topic that's interesting to me, because of course I'm working on electric vehicles, is CanBus and ODB2. And a friend of mine up in Golden is doing some work with the MCP 2515 chip and stuff. And just wondering what's the best resource there for, ideally for the P2, but even the P1. What's the CanBus ODB2 situation like out there?
You talked about the car OBT
Oh, that,
thingy. Got one of those. My husband uses it.
that's a CanBus apparatus? I never knew. I
Yeah,
know-
basically, as far as I know, for the P1, there is some software for that MPC 24 and the companion chip. There are two of them. There is some driver for the P1 out in the OBEX since years, but it should be portable to the P2. I mean, it's a simple serial protocol, isn't it?
Yeah, it was simple is probably
Yeah,
it's more
not simple.
packet decoding, but yeah, and my friend I think is working on trying to do some of that porting work from the P1 to the P2. I'm just wondering, as I'm going to be starting up on the P2 in the fall, what resources were out there already for indeed the MCP 2515 chip or other similar devices.
Yeah, I'm working with electrical vehicles too, and I'm interested in the same thing basically, but I'm so stunned with work right now that I can't do any P2 stuff, but CanBus should be possible definitely, and it's very needed in my opinion also, because you have to read all this bullshit out of the controllers and stuff. And I'm playing around with old electric vehicles, you know, like a Porsche 952 electric, converted 20 years ago, and now I have to refix it. Yeah. No, I'm kind of working with some guy who did electric conversions since 30 years, Peter Zankowski. And he needs help there with controllers, and I think we are building some new ones now. It's very interesting, and the P2 is pretty good for that. I'm excited. So maybe we can share resources there somehow.
Yeah, well, you're absolutely right. With the way the CAN bus works these days, like the Nissan Leaf that I'm working on has multiple CAN buses. And so obviously you could process those in each one of the Cogs and share the resources. And then if you're trying to do bridging or interpretation and controlling a car, having one CAN bus Cog and a second CAN bus Cog, and then a third one to output the data or manipulate the data before you pass it on, would be very it would be significant to have that capability.
I'm exactly, I'm with you there, and I'm looking forward to it, because currently the software we have on our controllers runs on some Arduino code 10 years old. I hate it. I want to replace it, but Peter is not really up to replace it right now, but I'm working on it.
Right. Yeah, I've got some more recent code on 80 mega 64 chips. It's kind of just raw hardware that does the bridging, and it's got 3 CAN bus ports, and that it's not really fast enough. And I think the P2 would be fast enough, given that each of the CAN buses would be operated independently.
I have that thing on my Mercedes. It has 2 CAN buses with different speed.
Yeah.
Stupid, but they do. It's an old, I don't know, 1993 SL500. So it's an old car, but still, I have to kind of get it running, keep it running.
Yeah, well, the CAN bus is an ideal opportunity for dissuading people to access their right to repair, because the more CAN buses at different speeds you have, and the more error control software that you have to make sure that messaging isn't coming from outside of the car, the more difficult it is to hack.
Brian Thomas, do you have a question? I see your hand is up.
Yeah, Chip, before you go, you had mentioned a while back that your driver board for the motor board might be able to run the transformer. Is it? Do you still feel that way, that it would drive one hard enough?
Sure. Yeah, why not? It could run a transformer.
Okay. All right.
But you know, you're limited to 40 volts though.
Now, you could just change the transformer. It's no problem.
Yeah, it could definitely drive a transformer.
All right. Thank you.
Just a comment for those who don't know Brian, he made a product with the Propeller 1 that tests the hardness of high school football fields before playing, and is quite successful. So it's good to see him back here.
Yes, I worked on one last week, and from Ohio, he sent me a $100 gift card for Outback. So I'm dying to make use of that.
I'm sure you'll enjoy that.
Stupid woman question. Why do you have to test football fields for the hardness? Aren't you just supposed to play on whatever God gave you to walk on?
Well, that was true at one time, but then the era of everybody suing each other over the least little thing. So ASTM stepped in, and if it's too soft, they'll twist ankles. If it's too hard, they'll break kneecaps. So they decided on a certain hardness, and every field has to be tested before a game.
This in a game that entails people running into each other as hard as they can?
Yes, ma'am, afraid so.
I don't understand it.
Well, it's also for certain hardness, like at the exit ramps for people with wheelchairs. They have to test them for other hardnesses, and playgrounds. There's a Propeller out there testing at your local McDonald's, believe it or not. They'll use their equipment there to test the playgrounds for the kids, soccer fields, baseball fields, all that.
Never knew that.
It's not a big market, but we sure had fun with it back in the day.
Yeah. Thank you.
You're welcome.
Well, maybe we could use the last couple of minutes to see what would be of interest for future meetings and what people need, because we're trying to respond to that. So I heard a request for a CanBus object, which has come up before.
Yeah, I have another one for you, or for Chip, basically. Having the debug and terminal, I mean, all the debug stuff is now in the prop tool. And in my opinion, all that debug stuff belongs into the prop terminal. So that I can use FlexProp or whatever to put out, or even my own assembler program to put out debug statements, and they are interpreted by the Propeller tool terminal thing instead of the prop tool itself. So in my opinion, all that debug stuff should move into the Propeller serial terminal, PST.
Right.
So that you can use it from any other application, and even this kind of, I don't know, the basic stamp or whatever. In my opinion, it doesn't belong into Peanut and prop tool. It belongs, the debug belongs into PST. Short question. and that should run on your Lazarus Delphi instead of what you are using. So then it would be kind of compilable on Mac and Linux also. So you should look at that free Pascal, free Delphi, free Lazarus. There are a couple of those out which can do cross-platform applications, and I think prop terminal and debug could be a nice single thing which can be run on different platforms instead of Peanut.
We would need to switch on prop terminal so that as it took in data, it would know whether or not to interpret it as debug. it couldn't do everything automatically. You'd have to put it into a mode where it would become sensitive. Otherwise, but yeah, that could be done. I see your point. You should be able to just feed data. You should be able to receive serial data and then see the debug stuff happen.
Yeah, and the main point is, currently the PST can't be a really big program. I don't think. I mean, okay, you have that switching of serial ports without reset, but basically that should run in 3 Pascal or Lazarus or even the Delphi, the new Delphi edition, which
what's it written in, Chip?
They are all cross-platform, and Prop Tool and Europe Pascal currently isn't. If you would switch it, I mean, Prop Tool is a small program compared to the PST is a small program compared to Peanut and all the other assembler containing kit. That should basically be able that you move that to 3 Pascal, and then we can run it on Mac, on Linux, on Windows, and using any other software we want. I mean, it would be nice to have that.
Well, you know that Peanut can do that. You know,
in my opinion, it would fit better to PST doing the terminal output and doing the graphics output, and not Peanut or Prop Tool. I mean, it belongs in the other program, in my opinion.
Yeah.
What's PST written in, Chip?
Parallax serial terminal.
Yeah.
Probably Pascal too, Delphi.
So you can use Peanut. You can say Peanut/debug and give it an optional serial port, an optional baud rate, and it will start listening to that port without doing anything else. It will just listen to that port and then run the debug stuff. So it's kind of like a command line PST that does debug.
But what's PST written in, Chip?
Parallax serial terminal. It's the one that's built into the propeller.
What language is it written in?
Oh, what language is it written in? I'm sorry. I believe it's Delphi with everything else.
Yeah, and you can, Delphi is now multi-platform if you would use a newer version, and you can use 3 Pascal also and other. I mean, you could try to move that thing. I mean,
You can write in Python.
It would be nice to have those debug screens on other. I mean, I'm personally just using Windows, so I don't really care about, but I think it would be a very good point to have those debug screens on Linux machines also, and usable for, let's say, Eric, who currently needs to rebuild all this in his tool, except if you would provide the PST doing the debug statements also, you could just call it and good. I mean, it's an external executable program, and it needs to interpret the terminal sequence and figure out the debug commands and display them. It would be nice to have it in there instead of Prop Tool or Peanut, because then it's usable from other tools also. And it would be very nice if you do that with 3 Pascal or whatever, to have it platform independent.
Well, comment noted.
Yeah, comment noted. Okay.
It's a big discussion, and it definitely involves backing up and doing things a different way. But at the moment, Chip's on the fork of the floating point math, and then he needs to come back to debug, and maybe we could take out this bigger issue. Because what you're talking about, Michael, and I agree with so much of it, and I'm so glad we have Eric to rescue us in the meantime with some Mac and Linux support. And without him, we'd really be a little bit less relevant. So hold the thought.
Chip, can you send me the PST source and I'll have a look at it? Because it's something that could be written outside of Parallax.
Jeff has it, I don't, but what I'll do is I'm writing him a little email now to ask about this. So I'll ask him to send you the PST source.
So Ray, with the effort you're working on with the interpreter a while back, or the compiler, did you close up that shop?
No, I didn't. I didn't ever get anywhere with it.
Okay. We can get you the source code for this. This might be more manageable.
Yeah. I want to ask the question. Ada's trying to put the spin interpreter compiler into Eric's compiler. Chip, you shared the source of Peanut with me. Can I give that to her? It's an old version, but
Yeah, go ahead. Yep.
okay. I told her I had it, but I couldn't give it to her unless I got your approval.
Yeah,
No, that's fine,
I
yeah.
have to say that we have to thank Würfel a lot for. I mean, she is a good coder. I mean, I honestly like to read her source. Whatever I could grab, she is nice, and she seems to work with Eric together because I have the P1 bytecode in there. It's a bomb. I like it.
I also
No,
have
Ada is great. Yeah.
I have a stack of
Ada
contributions
is a
from her.
great person. Yeah. I mean, yeah. I don't know her, but I mean, what she is doing is nice. I mean, honestly, nice.
And I have a question.
Okay.
Since we're talking about moving languages around, one of the things I've kind of been looking at, but don't know if I have all the skills to do it. Because the MicroBit uses a Blockly type language also, I'm wondering if there's any way to port the MicroBit into Blockly prop. And then I could program the whole thing in one very easily. And that would work with kids who want to program easily because, you know, all the block languages are becoming so popular now.
So that firmware was written in C, so we can't just automatically make blocks from it. But when I get it to you, you would probably envision how it was created, how it could be created in Blockly prop. I don't think that's out of the question. So,
is there still the capability in the offline Blockly prop to make your own objects?
yeah, you can do inline C.
Okay.
Yeah, so that's interesting. It seems like you could actually plop that whole entire source code in there.
Yeah, so that's kind of what I'm thinking.
Parse it out. And just use the pieces you needed and intersperse it with blocks. I think you can do that. So do you have that firmware? Did I send it to you? Yeah, I don't even know if we've posted it because generally people don't ask for it. The firmware that's in the Cyberbot.
I thought it might be online, but no, I don't have it yet. You can go ahead and send it to me and that'll cover it.
Writing a message now. I think it might be posted, but I'll find out. Andy will know.
And I should get going. I've got to get on the road.
Okay, sounds good. And then when you get to Rockland, drop off those parts, bring back a bunch of aluminum and a few other things you have to do.
Right. Okie doke. All right, I'll be there in a few
All right,
hours.
well, we're going to adjourn the meeting and we'll meet next week. Same time, same place. We don't know if it'll be Wednesday or Thursday though.
Great to see everybody.
Thank you everybody for joining today.
Yeah, Ken, I'll try to get the one bot to you as soon as I can.
Okay.
The one an activity board, because it does multitask.
I'll roll with whatever you provide. That's my favorite robot, is, you know,
Okay.
the blue board.
You like the alligator too?
Yeah. All right. Thanks, everybody. Have a good day, morning, evening.
Good night.
Cheers.